and inspecting variables. And there's nothing wrong with that. A well-placed breakpoint, I like to say, is like it can be as effective as a two-legged man in a butt-kicking contest. But we can do a lot better than that, especially when it comes to inspecting variables. And that's what I want to talk about to you today, inspecting variables. My name is Ijaz, and I am a mobile lead at Global Business Aviation. We provide voice and data connectivity for passengers and pilots on private jets. In my spare time, I'm working as a technical advisor for an application that connects parents in the US with kids in orphanage in India. And this is an API first application. So I'm in the process of building it right now. I wish I could have shown you a prototype, but I don't have a prototype yet. I just have the API. Today I want to talk to you about the LLDB debugger. The LLDB debugger is the debugger that comes standard with Xcode. It's a high-performance debugger, and it's been around since Xcode 4.3. And it's a great debugger. It works really well. It makes debugging smooth and efficient and fast. But I've noticed that there are a few annoyances with it. And by themselves, these annoyances aren't really that big of a deal. But you run into these annoyances every day, day in and day out, for days, weeks, and years. They add up. They add a friction to what should be a really smooth debugging process. So what I want to show you today are three things that I did, three things that I learned over time that allow me to Xcode, to extend LLDB to make it even better than it is right now. These three extensions that I'm going to show you today have helped me tremendously. I cannot exaggerate just how much better that made my debugging experience, and I hope that they will help you as well. I'm going to start off right away with the demos. We're not going to have too many slides. This is my sample app. It's an app for a fictional conference. It's a conference app for a fictional conference. It's called MyConf. The project is called MyConf, and that is actually relevant. You'll see that in a few minutes. It's a very straightforward UI table view controller over here. Okay, so here is my UI table view controller. So it's a simple UI table view controller. You drill down from the master view controller. You can drill into the detail view controller. Nothing too fancy about it. The bug that we're going to look at today is the bug that causes one of the cells to not show the session title. You'll see towards the bottom of the cell for a speaker name add there's no session title. So the way I'm going to debug this is I'm going to do the same thing that we always do, is start with a breakpoint. And I'll put a breakpoint at where I think I can expect to see the problem start occurring. And that's going to be in prepare for segue. Because in prepare for segue, in my master view controller, I actually have a session object. So here's my master view controller. Somewhere in here is prepare for segue. And actually, you know what? Before I do that, I want to cover one thing that Kendall had covered in his workshop on Sunday, and I want to make sure that everyone is on the same page. What I'm going to do over here in my viewed load, where's viewed load? In viewed load, I'm going to set up a breakpoint. And in my breakpoint, you see over here, my app says the navigation title is MyConf. In viewed load, I'm going to set a breakpoint. I'm going to double click on the breakpoint right here. I'm going to add an action, a debugger command action. And right here, I'm going to send a command to the debugger when I pause at this breakpoint. And the command is going to be expr, which says print or display the value of this. But if you have an expression, what expr actually does is it evaluates the expression in the scope at which the debugger has paused. So what I'm going to do is, instead of just printing a variable, I'm actually going to set a variable from within my breakpoint. I'm going to say self.navigation item.title equals what? Because I missed my kids. And I'm going to automatically continue. So let's quit the app, rerun the app, and you shall see what's happening is LLDB is setting up a breakpoint, and then it's executing Swift code, and it's actually changing variables, and it's changing the behavior of my app without me changing my source code. So this is a really useful thing. This is the first thing I want to show you. This is a very useful thing when you want to debug without changing code. Or if it's not easy to change a variable because of the path that the variable takes and you just want to change it at this point, you can use expr or PO. All right, let's get rid of this breakpoint. So I set a breakpoint in prepare for segue right here. If anyone can't see, if the font is too light, please let me know. So right here I have a session object and I should be able to investigate it. I'm going to start clicking on a success case first so I can get a baseline as to what I should expect once I click on a failure case. So now my app stopped over here and immediately I see two things that I don't like at all. What you see over here is what LLDB thinks are the variables in my current stack frame. So the list of variables is on the right-hand side in bold, followed by an equal, followed by what LLDB thinks is a good representation of the values of the variables. What's important is that this is not executing Swift code to display these variables. We're not calling description on an object, or if this were an Objective-C program, we're not calling description on the Objective-C object. LLDB is doing its best to figure out what is a good summary for variables of these types. Let's look at index path. Index path tells me absolutely nothing. It's the most useless piece of information right here. Every UI table view controller index path always has two items associated with it, the section number and the row number. That is nothing new. I don't need to know that. I know that. It's been that way forever. What I want to see is the actual section number and the row number right over there. And yes, I can drill down and look at it right here. See, index path has something called underscore indexes, which is a index path that's storage, and it's a pair. And the pair has two integers, and the first integer is obviously the section number and the row number. At least that's what I think. It's not really obvious to me. I want to see that information right there. Similarly, I want to see my session information right here. Looking at this, I can't tell which session I tapped. Did I tap on the right session? Again, I can expand this and look down. Okay, it's session keynote. Who's the speaker again? Did anyone catch the speaker's name? Oh, it's right here. I got to click over here, scroll down. Oh, Bishan Meng. That's cool. It's nice that I can do that, but I want to see it right here because the address doesn't tell me anything. I want to see it right there. What I really want is to tell LLDB the algorithm that you're using to display the summary for these variables is not working for me. I want some other information. I want to tell LLDB this is how I want you to do it. So I want to direct LLDB to create new summaries or summary strings for at least these two types, for objects of these two types. Now LLDB gives me a way to do that. I'm here, since I had a breakpoint, I'm here at the LLDB prompt. Hope everyone can see that. I can say, type summary add. I want to add a summary string for an index path. Look at that, all the way at the end it says objects of type index path. I want to add a summary string for index path. What is a summary string? It's this string right here. It's a simple string with some simple string substitution. You remember we saw indexes and pair. The 0th element has got to be the section, the 1st element has to be the row. So that's what I want to tell LLDB to do. I hit enter, and as soon as I hit enter, nothing changes. The reason nothing changes is because LLDB hasn't had an opportunity to reevaluate this index path. Now what I could do is start the breakpoint or continue and hit the breakpoint again, but I don't really want to do that right now because we're running out of time. So I'm just going to type N for next. Our index path is still in scope, and now it shows me section 1, row 0. And that I like a lot. So that was pretty easy. Almost all of my apps have the UI table view control. This is a very useful debugging or inspecting tool for me. So I want this every time. I don't want to have to hit an artificial breakpoint and type this in. I want this to happen with every Xcode project that I write. So what I'm going to do is open up a file called .lldbinit in my home directory. I'm just going to add the command right here. Now, every time Xcode starts up, LLDB starts up, it's going to evaluate this string, and it's going to give me this type summary for index paths. So that's great. I don't want to quit LLDB right now. I'll do that in a second because we have one other problem we need to look at, and that's sessions. So we saw that session has two things that I care about. It has a session title and it has a speaker name. Now, in the case of a normal session like a keynote, what I want the summary string to say is keynote by Bishamni, blah 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 by so and so. That's straightforward. I can do that with the type summary. So I'm not going to do that right now because it doesn't work when I have special sessions like break. There's no speaker associated with the break session. If I put a type summary in here, all I get is string substitution. It's going to say break by nil. So that's not good. I don't like that. I want it to say just break. So what I really want is to be able to do some sort of conditionals, basically, just looking at the speaker name. Is there a speaker associated with this? If there is a speaker, I want the code to follow this path. If there is no speaker, I want the summary string to be constructed this way. What I really want is a more powerful programming language to construct these summary strings, something that's more expressive than simple $string substitutions. Turns out LLDB does have access to a more powerful programming language, and that programming language is Python. So right here, I'm going to type in script. That takes me to the Python interpreter. So this is a full-fledged Python interpreter that I can use right within LLDB. What LLDB does is it invokes this Python interpreter. So there's a separate Python process running right now. And there's a connection between these two things. This Python interpreter can connect to LLDB, the LLDB that invoked it through a module that springs into existence called LLDB. And through Python, I can send commands to LLDB, and I can get information from LLDB. Let's have a look. I want to query what my current stack frame is so that I can see where LLDB has paused, where I set my breakpoint. So in Python, I'm creating a Python variable called frame that gets my current stack frame. If I type in frame to view the variable, it says that this is a Python object. It's a Python object of type LLDB : SB frame. SB stands for scripting bridge, which is a Python module, the series of the collection of Python classes that allow us to bridge between Python and LLDB. That's really useful. If I have access to my stack frame, what does the stack frame contain? It contains my variables. I should be able to access my variables. I know that since I'm the developer, I know that there's a variable here called session. There is a variable in my stack frame whose name is SESSION. It's a string that represents the name of the variable that is in the current stack frame that LLDB has paused at. So I get a pointer to that representation of the variable. This is not a Swift variable right here because we're not in Swift. We're in Python. This is a Python representation of a Swift variable in the current stack frame. So I can't use it like I would use a Swift variable. But as a developer, I know that there is a sub-variable within this session called title. So I can say, well, give me session.getChildMember with name title. Give me the title. Surprise, surprise. That is also an SB value. It's a Python object. Now, as a developer, I know that this is a string. Now I can tell LLDB, give me the description of this object. I don't know what this object is by looking at it. I can't tell that it's a string by looking at this. But I can ask Python, I can ask LLDB, give me the description of the string. So I'll do the same thing and I'll tag on get object description. Right there. Now, I get what I'm really looking for. Keynote. See that right there? This is what I was trying to get at. Everything else around it is a result of the fact that this is an optional string in Swift. And this is how LLDB gives me a description of an optional string. I just want the word keynote, or whatever is in the double quotes. I don't want all that other stuff. So what you'll see me doing in a second is I'm going to write as a regular expression to get rid of all the other junk, so I just get the title. But this is good. This is what I was looking at. Now that I know how to access these individual variables, I can actually write a program or a small script, really a function in Python, to construct a summary string for objects, Swift objects of type session in the module called myconf, which is the name of this app. So here's what I'm going to do. Go back to my terminal, save this, go back to my terminal. I'm going to open up a file. I'm going to create a new file called sessionformatter.py. I can call it whatever I want. I choose to call it sessionformatter.py. I'm going to create a simple function that takes something that looks like that string that LLDB displayed and extract everything other than what's inside the quotes. This is just a helper function. It uses regular expressions to get just the data that I care about. The real juice of the program starts now. I'm going to create a function. I can call it whatever I want. To stress that point, I'm going to call it food. There is nothing special about this name. Today I call it food. I'm going to say that this function, food, is going to be the function that I tell LLDB to invoke when LLDB should tell me the value of a session object. So LLDB has to call this function. Because this is the function that LLDB calls, it has to have a particular function signature. It's got to have two parameters. First one is val_obj. Second one is an internal dictionary which we can't use. We don't have access to. Just like I did from within Xcode, I'm going to, since I have val_obj, which is that SB value that we saw earlier, I'm going to get, I know val_obj is a session object because this is the formatter for session objects. So that is an implicit truth. I'm going to get a title by saying get child member with name title. From the session, I'm going to get the speaker, get child member with name speaker. And then from the speaker, I'm going to get the speaker's child member with name. So I've got the session title and the speaker name. Those are the two things that I care about. Speaker was just a temporary variable in the middle, so I don't have a very long line of text. Got the session title, I've got the name. Now, this is what I'm using Python for, because now I have an if statement. This is what I could not do in my session summary string. I have a simple if statement. If we have a name, I want to return the string which is title by name. And I'm using those that helper function to strip out the junk around the quotes. Else, if I don't have a name, return just the title. This is why I jumped into Python, so I could do this. Now you can imagine with a first-class high-level language like Python, there's a whole bunch of stuff I could do here. I could access the web if I wanted to get the value of a variable. I don't know why I do that, but I can do a whole bunch of stuff right here. I could access hardware if I needed to. So this is the end of this function because either way it returns a string. Now what I need to do is I need to tell LLDB that this is the function you need to invoke when you're trying to print out a value of a session object. And that's this over here. When LLDB imports a Python file, it promises me that it will run this function if this function exists in this file. This function's name has to be underscore LLDB underscore init underscore module. And it's going to have two parameters, the debugger and an unused parameter or internal only parameter called dictionary. LLDB says if this function exists, I'll invoke it. So this is, you can think of this as one extra level of indirection because what I'm going to do here is I'm going to tell LLDB, use this foo function to display the variables of type session. Debugger.handle command. This is where we see the connection between Python and LLDB, the explicit connection. Python is telling the debugger, it's as if I typed it in from the command line, type summary add. We saw that before, but now instead of summary string, it says Python function. Add this Python function Python function named foo, which is what I called it over here, in the module session formatter. What is the Python module? It's the name of the file. Session formatter.foo. So call the function session formatter.foo for objects of type session with a capital S in the module myconf. Myconf is the name of my app. It's the project. And then just so that I can see that something happened, I'm going to print the formatter for myconf that session has been set up. Save this. Go back to Xcode. Now I can go ahead and import this from within Xcode, from LLDB. There are two ways we can do this. I could import this Python file from within my tilde.lldb init. Remember that file where we put the summary string? Problem is, unlike index tags, there's only one app that I work on, or one app in the world that uses my session class. I don't want to have the overhead of interpreting this Python file for every Xcode project that I run. I just want it to be run in this one project and no other project. So I need it to happen just here. An easy way to do this is to set a breakpoint where I know the breakpoint will be hit. And that is in the case of an iOS app. Application did finish launching. So go to my app delegate. In application did finish launching, I'm going to set up a breakpoint right here. Double click on it. I'm going to add an action, a debugger command. I'm going to tell the debugger in application did finish launching with options. Command script import this session formatter.py file that I just created. Okay. Automatically continue after evaluating actions. That way I don't pause over here, and the app just continues to run as if nothing really happened. But you and I both know it's going to be a little slower on startup because it's now importing a Python file and evaluating a Python file. But I'll only take that performance hit in this project and in no other projects. Now, just to show you that everything's set up, and to confirm that everything's set up properly, I'm going to quit Xcode, relaunch Xcode, because if I haven't made any typos, this should just work now. Both index paths and session objects should be printed properly. Now, this is going to happen a little fast, so pay attention to where the session object is supposed to show up when I hit the breakpoint, and you may notice something interesting. So let me run the app. So you see on the right here, somewhere right here. So pay attention right here somewhere. Okay, I'm going to go back to my success case. Did you catch that? I don't know if you did. But here, index path is working correctly. Keynote by Bishan May is working correctly. The thing that I want to show you is for about 3/4 of a second, it had the wrong thing. It had the address because it was interpreting the Python file. So there's a performance hit. This isn't free. If you don't need it, you can feel free to turn it off. Just disable that breakpoint, and then you don't get the performance hit every time. So that's what I want to show you. So let's test out. Let's continue, and let's test out break. Yep, break works. Index path works. Very nice. Continue, and of course we haven't even we've been busy shaving our yak. We haven't really fixed the real problem yet. This now shows nil by adding t. So we're going to go ahead and look into that right now. But before we do that, we have 18 minutes and 58 seconds, so we're doing pretty well on time. I'm going to go back to the slides for a second. And we'll take a little breather. We covered a lot of stuff, so I'm going to just pause for 5 seconds. Talk amongst yourselves. If you were talking, Industrial Revolution was either industrial or a revolution. All right, let's recap. What did we see? The first thing we saw. I must have not saved one slide. The first thing we saw is what I wanted to show you with setting breakpoints. As Kendall had mentioned on his workshop on Sunday, you can set breakpoints and you can actually change the values of variables. And you might see this in the next slide. I might have to things over. But we also saw summary strings. Summary strings, you can have simple string substitution in LLDB. And you can put that in LLDB index so that I can say, for index paths, this is what I want an index path to look like. One of the last slides in this presentation has a link to the GitHub repo. In the GitHub repo, it's an older version. It works with Xcode 8, not with Xcode 9. So I'll update that later tonight. But what's in the GitHub repo will not work. It will be changed at some point between Xcode 8 and 9. So anyway, so this is the current version. Okay, here it is. We saw changing variables. We saw that I could do something like, instead of saying expr variable or print the value of the variable, I can add an assignment at the end and it actually runs that assignment. What it's really doing is this in Swift, it puts, you have to think of the fact that it puts two braces and it calls do, and it runs, it creates its own scope and it executes, it tells the debugger to execute the code that you type in after expr in its own scope. What that means is if I type in expr my variable equals 5, and if my variable didn't exist in the existing scope, I would have to say var my variable equals 5. And what this also means is if I say in the next line expr my variable equals 6, that's going to fail because they're in two different scopes and they can't see each other. But if we're looking at the parent scope, it's going to work. In Objective-C, you can think of it as not having to do it, but just having its own scope with these two braces. We also saw that we can write a 7-line function in Python to get a reasonable summary for a complicated Swift object. We also saw that we can do project-specific loading by putting a breakpoint, by setting a breakpoint in application definition launching, or if we're writing a command line app or something, we can put the breakpoint in main. Any questions about what we've covered so far? Yes?
I guess my main question is, if you have an overly complex app, it's got many screens, how do you know when it's going to call those specific functions, like the food function, for instance? How do you know when it's called on that one screen versus on every screen?
So the question is, how do you know that the food function is going to be called on one screen, did you say?
Yeah, one view control.
Oh, one view versus another view. The full function will be called every time LLDB needs to describe to me what the value of the session object is. So if I have a breakpoint that prints the value of a session object in my console, it's going to be called every single time in every screen. So it has nothing to do with the screens. It's not going to be called every time an object is used, but only when I ask LLDB to display it. So it's not going to happen very often. So it's okay if I have like a whole bunch of 1,000 sessions on every screen. It's only going to happen when I hit the breakpoint for every session in my stack. So if I have 500 sessions as stack variables, yeah, you'll see it. That's a great example. I should try to see this if I can get it to slow down. I might just do that. Yeah. Any other questions?
So have you ever connected it to any type of logging so that maybe you can run an automated test and have the logs?
Have I
analyzed afterwards for patterns, normal patterns?
So the question is, have I ever connected this to any sort of logging so I can analyze the logs later? Me personally, I don't think I have, but there's nothing preventing me from doing it because I could say print the value of the session, so print to the console, and then I can just select the console and then parse it. Select the console output and parse it, yeah. And I will see something very similar to that in the next session. Any other questions?
Is there a way to, instead of having to recreate these breakpoints that imports Python scripts every time someone on the team checks out the project, is there a way to like run a script that will create breakpoints for you?
Yes. So the question is, it's not having to set these breakpoints every time. Can I just create these breakpoints so they're there every time I stop the app? Or maybe, and I'm going to add to your question, maybe I can have them in source control so that someone else can look at them. Yes, there are a few different ways you can do that. I'm going to go over a couple real quickly. There's a breakpoint file. I don't know if you noticed, but when I was setting up, I had a /reset, which kills my breakpoint file and resets everything so I don't have any breakpoints. But you could check the actual breakpoint file. What I prefer to do is set the breakpoint file in an LLDB init file or in a separate init file, and I can set the breakpoints in there, and then I can import that init file from active finish launching as opposed to just running a Python script. That way, for each project, you can have your standard breakpoints and your standard functions that are in source control that have nothing to do with the project hierarchy. And they're just simple text files. Yes? Any other questions? Okay. All right. This is JSON. So, remember I told you that this app that we're working on is an API first app. It's a really complicated app, and I haven't written a single line of code for iOS, Android, or I don't know Android. But anyway, most apps, I would say, having zero authority about it whatsoever. I would say that many iOS apps, many Android apps, also act as web clients. We get data in some form or the other from the web. And the majority of the time when we do this, we get data in JSON. The JSON is a real popular format. Can I just see a show of hands? Anyone use get data, JSON data? Okay, good. So I'm reasonably right. We do it a lot. This is what JSON looks like. It's really nice. It's easy to read. It's easy to parse. And as you right here, I've got an image, and I need a tree, a Twitter, a chat, a co-author, blah, blah, blah. But we all know this is not what JSON looks like because we want to reduce the payload, and what JSON really looks like is this. And there's no way I'm going to read this, right? And I'm 99% sure as the developer that this bug we're seeing is because the JSON looks bad. But I need to prove it to the backend developers and tell them that the JSON is bad, and that's why we're not showing the session type. I want a way to extract that one person's session from this JSON data. And this is actually the JSON data for this app that we're seeing. So this is the real JSON file. I Googled, and I found this app called JQ, which was written about 10 years ago, maybe longer. It's written in C. It was last updated in 2015. And that doesn't mean that it's abandoned. It's an amazingly useful app. If you ever write a REST client, or you ever download JSON, you ever have to parse JSON, or worse, debug JSON, I would strongly recommend that you download JQ. It's a C app, purely written C, zero dependencies. It runs on Windows, Mac, Linux, and it allows you to parse and manipulate JSON. I want to show you a couple of examples of that. I'm going to use a sample JSON file from characters of my favorite TV show, Avatar: The Last Airbender. Actually, it's on the slides. Yeah, Avatar fans, excellent. What a try! So, those of you who get it know that was the best thing in the movie. So this is my JSON file. I downloaded this file into usable JQ. JQ avatar validation. There's a command and there's an input file. In the middle, I have something called dot. Dot is the program that I want JQ to run. It's known as the filter. It's the simplest filter that is available in JQ. It does absolutely nothing other than print the JSON. When I do this on the avatar.json file that I showed you, this is what I get. And it scrolls off the screen, obviously, because it's a huge file. But there's a lot of useful information just in the last two lines. The last line tells me that this is an array. The second last line tells me it's an array of objects. Really, really useful. I can iterate over these objects. This thing over here is the iterator construct in JQ. So it says for every item in this array, iterate over it. And that's my filter. Then I have a second filter called keys, which takes an object and prints out the keys, that object. Then what happens is I take the output of one filter and pipe it into the input of another filter. And then I get for every object, give me the keys for that object. That's what I get. For every one of the characters in Avatar, I have Bentley, born, children, died, identity, name, sex, spouse, Bentley, born, children, blah, blah, blah. Right? Really useful. So there's something a little bit more complex. Instead of just showing the keys, I want to extract a name field. So the same thing, iterate over the object, extract dot name. I get blah blah blah. Really useful. This is the killer feature of JQ, grep. I can grep my JSON. I'm saying for every item in my array, select those items where sex equals F, and then give me that character's name. Give me the name of all of the female characters in Avatar. And that's the list over there. Grep. Super useful. Let's go back to our demo. So I've shown you JQ. I've shown you how I can access JSON. So now what I need to do is I need to get to the point in my file, in my app, where I actually get my JSON string. And that's what I'm going to do right now. In my app right here, it's a file called network.swift. I'm going to go right here. And I'm just going to put everything inside an if debug so that I don't get this performance hit. It's a pretty big performance hit. So I don't get this performance hit in release. What I'm going to do is take my JSON data and convert it into a string, because I never really had it in a string format before. I'm not using it codable, but you can still use that. It's got nothing to do with how we decode and encode the JSON. I get a string, and now, because I don't like that warning, I'm just going to put in an NS log that prints the length of the string so I don't get a warning. Okay? There's no other reason for that. Run the app. Oh, I should set a breakpoint, shouldn't I? And did I lose my... I lost my mouse pointer again. What the heck is that? Alright. Quit. Stop tasks. I don't know why I lose my mouse pointer.
It's Keynote.
It's Keynote? Okay, well I can fix that. Thank you. I can always do this. It's okay if you see my slides. Okay. Am I running? No. 6 minutes, we should be fine. Alright, so I have set a breakpoint. I'm going to go right here. It doesn't really matter where because I get the same JSON for every object, so I can click anywhere. Oh, I didn't set a breakpoint, did I? I didn't set a breakpoint. Network.swift. Here's my breakpoint. Let's run this again. Alright, now I get my breakpoint right here. And here's what I want to do. I go print out JSON string. And this is what I used to do for 2 years. It's my JSON string. There's some extra backslashes in there. That's fine. I can deal with that. I can strip them out with Perl or with sed. I'm going to copy this. I'm going to go here and paste it, get rid of the quotes, save it in the file called /temp/result.json. And now I can run commands on my result.json, and then I can debug this, and I can look at it from right here. But I don't like this because I have to command tab, and I'm lazy, and I have to get out of Xcode. I want to do this, and unfortunately, I had this several times a day because we were working in an agile environment where, of course, agile means there aren't any requirements, so it was very frustrating. So, what I really want to do is this. Forget all of this. I really want to be able to go here and say, well, JQ, something like this, maybe keys of JSON string. And of course, it's not going to work because JQ is not a valid LLDB command. But I know how to make LLDB commands. I know how to extend LLDB using Python. So I'm going to do that real quickly in the next 4 minutes and 5 seconds. So go over here. I'm going to create a new file called jqfile.py. I can call it whatever I want. I'm going to import some libraries that I need. Oh, sorry. I'm going to create a new file called bar, again, but only because I want to stress to you that I can call it whatever I want. I'm going to get my frame, because I have a debugger. From the debugger, I can get my target. From my target, I can get my process. From my process, I can get my thread. From my thread, I can get my frame. Now I have my stat frame. And now that I have my stat frame, I can get my variables. I also have a command line in which I typed in, eventually, this is going to be my command line. So I'm going to parse these three things and try to get the information. So I'm going to do that right now. I'm going to take the command arguments. I'm going to get the filter, which is the zeroth arg. I'm going to get the string name, the name of the string, which is the actual string, JSON str. But then I need to get its object description. And then because this is Swift, I need to call eval on it. So I'll go ahead and do that. We can talk about that later. I'm going to write all of this information to a file to make it easier, so LLDB doesn't run out of memory. Then I'm going to call JQ. Use the local bin JQ with my filter file and with my JSON, which has been stored into a file called /temp/JSON. And then whatever output I get, which is this output variable, I'm going to print it into the result object, which was passed into me by LLDB. And because I'm printing something into result, that's what LLDB will display. I still need to tell LLDB that this is what I want you to use for, as a function. So I'm going to say LLDB init module. This is not type summary. So the command is slightly different. It says command script add a new function. That's what -f means. Add a new function. What Python function should be executed? Var in file name JQ file.py. JQ file.var. What do I want to call this new LLDB function? I want to call it JQ. That's what I'm saying over there. I'm going to save this real quickly. Get back here. I'm going to import this file. And I have invalid syntax. You know what? Just for this reason, I have another shortcut. Okay, the JQ file has been installed. Good. Now, I can do JQ keys. Look at that. Give me the name of the speaker, Adam Dean, and get me his ID, 3. His ID is 3. So, give me all the sessions where speaker ID 3 is the speaker, and there's the bug right there. One object is called session title, and one is called title. And this is something that I wind up doing many times a day. And that's not the point. I could fix this bug, because I could fix this bug pretty easily. The point is, 10 years ago, somebody wrote an application that they uploaded onto the internet because they thought it might be useful. In 2018, 3 years after this application had stopped being modified, I downloaded it, and now it's part of my LLDB environment. And I think that is super cool. It's helped me tremendously, and I hope it will help you as well. Real quickly, we've got 15 seconds. Let's get back here. What did we cover? Oh, good Lord. I'm going to run over. I don't want to start from the beginning. Let's recap. No, not that. That. So we saw we can create a JQ file, we can create new Python objects. We saw that we can import it and run the output of our commands right from over here. I'll take questions in a second. Just my take. If you want to take a picture of this, and I'll slack all of these as well. But this is where there is my GitHub repo is there. Needs to be updated a little bit. There's a blog post. These slides are already up there, and Facebook has a really nice library called Chisel. Lastly, these are all dub talks that I saw to get the information for this, right? What's really interesting is the ones that specifically address this talk are from 2012 and 2013. This stuff has been around for a while. My point is, watch these old videos. There's some really useful information. Thank you.